In this video, we are talking about more key features of quadratics. The first one we'll look at for each of these examples is called end behavior. So what is end behavior? It is simply what the ends of the graph are doing. So where the arrows on the graph would be, that is what we look at to consider the end behavior. So let's look at example number 1. In this parabola, we have it upwards facing, so the arrows would be here on the ends. And for the end behavior, you're always going to have the terms or the phrases so that means as your graph is going to the left or negative infinity, and then as your graph is going to the right or positive infinity, which direction is the graph moving? Is it going up or is it going down? So for example number 1, we have that this quadratic on the left arrow or on the left-hand side of the graph, it is moving up. And since this is the leftmost part of the graph, that means x is going to negative infinity. And since it's going up, that means that y is going to positive infinity. Then we'll look at the rightmost end of the graph. So since this arrow is going upward on the rightmost part, or where x is going to positive infinity and the graph is going up, that means that y is going to positive infinity. So we're going to continue this process for examples 2, 3, and 4. For example 2, we want to locate the ends of the graph. So there's an arrow and there's an arrow. Remember that as you move to the left, or x going to negative infinity, we want to look at what is y doing. Well, in this case, the graph is going down the more you move to the left. So as x goes to negative infinity, y goes to negative infinity. Then as the graph moves to the right, or as x goes to positive infinity, what is y doing? So is the graph going up or down? In this case, it's going down, so y is going to negative infinity. For example number 3, locate the ends of the graph, or where the arrows would go. So as the graph moves to the left, or as x goes to negative infinity, is the graph going up or down? Here it's going down. So as x goes to negative infinity, y goes to negative infinity. Then as your graph goes to the right, so on the right side of the vertex, we're going down again. So y is going to negative infinity there. Then example number 4. As we move to the left, or as x goes to negative infinity, what is the graph doing? It is going upward, so y is going to positive infinity. Now I want to note that you might not always see the plus sign there. That's okay. If there isn't a plus sign, it's still understood to be positive unless it has a negative in front of it. So from the vertex, as we move to the right on the x-axis, or as x goes to positive infinity, this graph is going upward, so y is going to positive infinity. Next, we're going to talk about when a graph is positive or negative. So for a graph to be positive, that just means that the y values are positive. And when the y values are positive, that means that the graph is above the x-axis, right? Because y equals 0 is the origin. So whenever a graph has a y value of 1 or 2, 3, and so on. Those are all positive y values, so we kind of shorten that term and just say that it's positive. Then when the graph is negative is when it's below the x-axis. So remember that the origin is 0, so if the y values are -1, -2, -3, and so on, we call that the negative part of the graph, or when the y values are negative. So we're going to look at this first graph and just highlight when that graph is positive and highlight when it's negative. So when it's positive means when is that graph above the x-axis. So it's above the x-axis here and here. So how can we describe those two sections of this graph? Well, we're going to describe when are these y values positive, or when is this graph positive based on the x values. So this graph is positive, or this is a positive y value at this x value, it's a positive y value at this x value, positive y value at this x, and so on. So we're saying between which x values are the y values positive, or at which x values is the graph above the x-axis. So it's positive or above the x-axis here for all of these x values. And they keep going on forever because this graph keeps going up forever, right? So when x is -5 or less, that's when this graph is positive. So when x is less than -5, I don't want that to look like an arrow. Let me rewrite that. When x is less than -5, there we go. But it's also positive at this point with that x value, and so on. Right? So all of this side of the graph is going to keep going right forever. So it's from this point, -1, forever. So when x is bigger than or greater than -1. Right, well then, what about this section of the graph that is below the x-axis? So from here, this little U-shaped part of the graph, that's actually between two x values. So it's between this x and this x, -5 and -1. So when x is between -5 and -1, okay, now let's look at example 2. The part of our graph that is positive is, this time it's the upside down U shape, and that's between these two x values, 1 and 3. So when x is between 1 and 3, it is positive. And then the parts of the graph that are below the x-axis, or negative. Okay, so for this one, since it's flipped upside down, it's going to be a little different. Okay, so this is a negative y value, this is a negative y value. All of these points on the graph are negative y values, and those happen at all of these x's. So as long as we are at the point 1 and going to the left, that graph is negative. So when x is less than -1, but also on this side of the graph, all of these y values are negative, right? So at all of these x values from the point 3 moving to the right, this graph is negative there also. So when x is bigger than 3. Okay, example 3. When is this graph positive? Well, it looks like it touches the x-axis at -1. Since this technically is 0, that's not positive or negative. So we have to think about this part of the graph and this part of the graph are negative, but technically when it's on that point, -1, 0, that y value is 0. So we want to say that it is negative. Let's look at those points. So all of these are negative. So it's for all of these x values, as long as we're not on -1, because this point itself is at the y value of 0, and 0 is not positive or negative. So from -1 all the way to -infinity is when this graph is negative. So as long as x is less than -1, and when x is bigger than -1, because look at this side of the graph, right? So from here, that's a negative point. These are all negative y value points. So from here on forever, all of these x values give us negative y value points. But we can't say that it's just always negative, because technically at this point, at the point -1, 0, because this has 0, that is not positive or negative. So it's kind of like it's always negative except for when it's on this specific point. At that particular point, it's not positive or negative. But when is it positive? It's never positive, because it never goes above the x-axis. That one's kind of tricky. You won't see too many like that if you're asked to describe positive or negative. You will most likely see them in the form of examples 1, 2, and 4. Finally, last example for positive and negative. So when is this graph above the x-axis, and when is it below the x-axis? Okay, so I've highlighted the different sections that we need to describe. We'll start with the positives. So from this point and going to the left, all of those y values are above the x-axis. So to write that in inequality notation, that's when x is at 1 or less. So when x is less than 1. Notice I'm not using the equal sign for the reason that we talked about in number 3. Okay, now when x is at 3 and then moving to the right, those are all positive y values. So when x is greater than 3. Now it's negative between these two x values, 1 and 3. So when x is between 1 and 3. Finally, we're going to look at increasing versus decreasing. So, increasing, what does that mean? So when you're tracing the graph from left to right, your pencil's either going up or it's going down. If it's going up, that's what we call increasing. If it's going down, that's what we call decreasing. The idea of it is pretty simple, but again, we're going to be writing this in interval notation, so that's where things might get a little confusing. All right, so for increasing, we're going to look at number 1, and we're just going to trace from left to right, okay? And I want you to think about this as we're doing it. Okay, so from the left part of the graph, I'm tracing and my pencil's going down until I get here at the vertex. So from here, we're going down, and then it turns and starts to go back up. Okay? So the part when we were moving down, that was called decreasing. So down until we get to the vertex is decreasing. I'll draw those little arrows to show you that that's the direction we were tracing. So which x values are we decreasing between? Okay, so remember this graph is coming from infinity, right? So it keeps on going that direction. So it's coming down, 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 down until it gets to the x value of -3. So when x is less than -3, that graph was going downward. Then it's increasing from the vertex going upward. Okay, so at -3 and moving to the right, so when x is greater than -3, it's increasing. So your vertex is always going to be, the x value of your vertex anyway, is going to be the point where your increasing and decreasing turns. Okay, number 2. Let's keep in mind where our vertex is. It's at the x value 2, so that's going to be our turning point. Okay, if we're tracing from left to right, so I'm going to start on the left, we're going up until we get to the vertex, and then we're going down. So we're increasing from -infinity up until we get to 2, x equals 2. So it's anytime that x is less than 2. From 2 all the way to the left. That graph is going up when you trace from left to right. Then from 2 going down, or moving to the right, the graph is decreasing. So when x is bigger than 2, that graph is decreasing. Okay, so I want to kind of draw this just to show you. So 2, or your vertex, the x value of your vertex, or the axis of symmetry, is always your turning point. So you're thinking about left versus right. Okay, so when x is at 2 or less than 2, the graph was increasing. When x was bigger than 2, it was decreasing. Okay, example number 3, increasing versus decreasing. Okay, so here's our axis of symmetry, or the x value for our vertex. If we trace from left to right, so starting on the left, we're going up, so we're increasing. So we're increasing on the left this time, so when x is less than -1, and decreasing when the graph is past the vertex, going to the right. So that's when x is moving to the right past the vertex, so that's when x is greater than -1. Okay, and then example number 4. From the left, this time we're going down until we get to the vertex, then we're going back up. So again, the vertex x value is at 2. X is 2. So we're looking at decreasing until the vertex. So that's when x is less than 2. And then we're looking at the vertex and moving to the right, we're going up. Whoops, I just wrote that in the wrong space. Let's move that. Decreasing. There we go. Okay, so decreasing was x is less than -2, so from the vertex going to the left. And then for the right side, from the vertex going to the right, it's going up. So when x is greater than 2, that's increasing.